All right. Okay, so I'm gonna try to solve this problem. Search a 2D matrix. Um, so, um, so what I was thinking was that my initial thought. So I've already put some thought into this problem. I've already been working on it, but I haven't actually like implemented the code. But what I was thinking is basically this is gonna be a straightforward, not straightforward necessarily, but it's a binary search. But but it's a binary search where it's like I don't know what to call it. Like, is it maybe it's a double binary search or something. So like, um, so what I was thinking was if your target is three, you binary search through the you binary search horizontally, and then you binary no you binary search row by row, and then you binary search column um binary search a row. Yeah, so you binary search row by row, and then you binary search a row. So basically, I guess the idea would be when you're binary searching row by row, for this first example, you're gonna have if the value at the end is greater than the target, then oh wait a second, no, let's say the value at the beginning of the row. So the first value in the row. If the first value in the row is smaller than the target, then it'll return true. And if the first value is greater than the target, it'll return false. So for this example, 1, 10, 23 is going to be true for 1, false for 10 because 10 is greater than 3, and false for 23. And my binary search will return the last occurrence of true. And that should work. So then once you do that, you found the row that you should search. For this example, the target is 13, so binary search, this would be true, this would be true, this would be false. So it's gonna get this row, the second row, and this one gets the first row. And then you binary search in that row. Um, Let me think. So you'll set your low and your high, equal to, since these are in sorted, I believe. Yeah, these are all sorted from left to row. And also the first integer of each row is greater than the last integer of the previous row. So it's also, this always will be larger than this. Okay. Yeah, so if this is always larger than this, if the element is less than this, it's definitely not going to be in anything after this. It has to be in the previous row. Okay. And then binary search the row, I think would be, um, I mean, yeah, binary search the row is just like, um, what would I do? I would get the low and high, and then, yeah, just a regular binary search in a linear thing. So like, if the value is less than, I guess it would be, or we could do this. We could do false, false, true, true. So we could say if the value is greater than, it'll be true. So like for the first row, for 1, 3, 5, 7. So looking at this one, it would be 1 will be false, 3 will be true, and these will be true. And then just return the first occurrence of true. Um, yeah, this is basic thing. I could do them all. I could do this one probably also like this. I could say FTT. I could say it's false if basically the value is less than. And no. I definitely want to do true, false, false because I want to return the last occurrence of true. Yeah. yeah, it just works out better. And then this works out better for this one, I'm pretty sure. So, okay. So, gotta think how I'm gonna do this. There's no constraints given? Okay, well, so we'll do the row and the column, length of m, and length of m0. And then, okay, so this would be that. And then, I'm gonna try to search through the rows. I said by looking at the first element, I think. Yeah, so we'll create definition, possible definition, row by row. And the value we're going to need is target. And I think we need I think I also need the row number. Yeah, index, or let's say row. And then what it's going to do is basically say return if m of this row value, and we're always going to use the first element. If it's less than or equal to the target, it'll return true. So that will include the case of, let's say we're searching for 10, so it'll return true for the second row. Okay, so then that'll be that. And I need another function that will work for search or target in row. Yeah, so this is going to check if the target's in the row. So um, you'll be given some row value, you'll be given some column value and some target. And then for this, I think the case was I was going to return if MRC is greater than the or equal to the target, I wanted to return true. Okay, cool. So like, yeah, that was my idea here. So return true here, because if you put 3, it's gonna be greater than equal. If you put 5, it's greater than equal. 7 is greater than equal. Okay, so then we're gonna do definition binary search. Obviously there's two different binary searches. One's gonna return the last occurrence of true, and one's gonna return the first occurrence of true. So there's two different binary searches. So I guess binary search, let's say row. I don't know what the inputs would be, but I know that low and high is going to be equal to 0 and then the number of rows minus 1 for high. And then you could do while low less than high, mid equals low plus high, and goal is to return the last occurrence of t. So I have to think about this, but I think if I'm pointing to this f here, at the end here, if I'm pointing to this last f, or yeah, let me think about this for a minute. And it's saying false. So if it's false, it's gonna move high past it. Yeah, okay. But true, you never want to move past. And also, yes, I think I need to do +1 and then divided by 2. And then I'll say if row by row, and then the current target value, or the current R value will be R, and the target will be, I mean, it'll be entered from up here, so yeah. Um, so if this is true, you want to move low to mid, right? Yeah. And if it's false, you're always going to move one great, you're never going to miss one if you do that. Okay. And else high equals mid minus 1. And then I guess return low. And then definition binary search um, in row. Okay. And then for this one, it's going to be different. This time, if it's true, we're going to want to move the high to the value. So yeah, so high is going to go to value. But if it's false, we can move low past that value. Okay. So it's going to be reverse order. But first let me set my low and high. So my low should be, actually this should have the row in it. Yeah. So it's going to be m row in the first element, and then the high will probably be m row the last element. Is that right? No, no, no. I think low high is supposed to be the index though. Yeah, it's just the index. So it would be 0 and c minus 1. Okay, now do while low is less than high, mid equals low plus high divided by 2 if not target in row for our current row, and C will be the mid and then target, and then what the algorithm should do is it should move mid low to mid plus 1. So that's just like, because if it was true, we want to put not, so it's going to change this to false, but it's going to move it past it because, or sorry, I'm looking at the wrong one. It's going to move this, F to true, so it's going to invert everything by having this not here. So it's going to look for true and false, false. So when it sees true, it's going to move it past it because this true is actually a false, and it's going to move to the F, and that's why I have low, mid, plus 1, and then high, though, cannot move past because I might miss the last F. So that's where high will be just equal to mid this time. And I think you want to not add 1 here because you always want to prefer the lower value here. Yeah, because you want to return the lower value. Here you want to return oh shit. Oh yeah, you want to return the lowest possible true. Here you want to print the highest possible true, so you want to prefer the more on the right side, as far as I understand it. But okay, and then return low, and then okay, so then what I should implement is I'm gonna actually do these searches. So the first thing is the row is gonna be equal to binary search row, right? So we do that, we get the row, and then we get candidate, I guess a candidate value, binary search in row with the row value, and the candidate value it's either going to be equal to 3 or like for this case of 13, it's going to return, see, so in case of 3, it returns 3. In the case of 13, the last true will be the 16. So we're going to return basically target equal to can value. So I mean, if it's equal to can value, it's true. If it's not, it's false. Okay, and then run code, test it out. So, okay. I wonder if it's working for this one though. Alright, run code. Okay. Alright, so it's getting false, false no matter what for some reason. Okay, so might be something wrong. Maybe this is divided by 2. It's a lot of steps, so let's just do some print statements. Let's print out what value does it find. I think that would be interesting. Also, what row does it find? That'd be interesting to know. Figure out maybe which binary search isn't working. Okay, 0 is correct, 1 is correct, so I think this one's working. But this returns 1. Oh, you know what? I'm returning the index value. Okay, sure. So actually I want to return row. Is this index value correct though? 1. Yeah, it looks like it's correct, so it's probably that. So then that will return the actual matrix value. Okay. Okay, so that's accepted. I could do some more edge cases. I'll just submit because I don't know what edge cases they're intending. Okay, they do have the edge case. I wasn't sure if they're gonna have that one. Okay, if not, I guess I should implement this regardless. Just assume that this could be an edge case. What's another edge case? Um, I think that's it actually. Whenever you have a problem like this, I guess return 0. Is there? Oh, you can also have that. What? Okay, if not M0, return 1. Okay, I'm confused about this. It's not returning, which is not showing what it returns. Um, actually, what should it return? What the heck? If it was empty, what would be the answer? Um, I mean, it's searching for a value in a matrix, so obviously you're not going to find the value if there's nothing, so it's got to be false. Because no matter what value you're looking for, you're not going to find it in this case, in these two edge cases. I should probably just do them down here too to make sure. And it doesn't matter what value, but I'll just do those two. I clicked on all that. Okay, this one. Okay, false, false. Alright, submit. See the next edge case anyways, which is probably... Okay, alright, it worked. Cool. Let me look over this real quick. So, yeah, so it's a double binary search. I don't know technically what that's called, but this was my intuition. It's actually rather like once you memorize these binary search templates, and for like if you're either you're finding the last occurrence is true or you're finding the first occurrence true, it becomes rather easy to implement them just knowing. You just kind of memorize which ones need a +1, which ones need this, and you kind of know that because the +1 is usually the one that favors um, the last value tree, and that favors the first value of to root. Okay. All right. There's a wrap there.